Hello everyone, welcome to Maths online class of Anand Medical Academy. I need every one of your attention towards this class. Why? Because this class is going to be very interesting and knowledge getting too. This class is regarding the entire topic of sets during this class. This class is very useful for the students who are studying class 11 and who joined for first PSC and also who are preparing for CET and also JEE Mains. Regarding this class, the starting concept of sets to the ending concept of Venn diagrams and the problems based on set theory. Right? Okay, now we will enter to the class based on sets versus collections. What do you mean by set and what do you mean by collection, and a representation of sets and its representation of sets and the types of sets, subset, power set, and again cardinality, nothing but problems based on power set and its Venn diagrams. So these are the topics we have covered in the previous classes, but the students who have missed those previous classes, we can get the topic easily in this class. So let us start with the sets versus collections. See guys, I will consider your presence toward the class is through likes and the comments regarding this class and in between the class too. Now coming to the topic, set versus collection. Set versus collection. See if they given a sentence, when we will call that as a set, when that is a collection. Every set is a collection, but every collection is not a set. See, for example, see my first question. Question number 1. Name the teams of IPL 2019. IPL 2019. So these are the teams which we have for IPL 2019. What are those? Mumbai Indians, CSK, Sunrisers Hyderabad, Delhi Daredevils, right? SRH. So these are the teams, and Kolkata Knight Riders. These are the teams. So how many we have? Those are 8, right? Those are 8 we have. Now if I ask her, name the best team in point of view. Name the best team. Name the best team in IPL. If I ask this question, in my point of view, the best team is Mumbai Indians. In your point of view, you tell in a comment. I will say. Oh, some are writing Chennai Super Kings, some are writing RCB. But when I told name the teams of IPL 2019, so those all will come. But when I said name the best team in IPL, difference will be there from one person to one person. I will tell it is Mumbai Indians. You may tell it is RCB, or some another person will consider it as CSK. It is differs. These will consider as collection. These will consider as collection. But when it comes to name the teams of IPL 2019, if I ask you also, only these are the teams. If I ask any other person also, only these are the teams of that IPL 2019. So that is set of 8 teams. So this we will consider as set. This we will consider as set. So if they ask name the best team, that we will consider as collection, not a set. You need to understand the difference. Set means a well-defined collection of elements. Well-defined collection of elements or numbers like that. Collection means whatever it may be. So based on your choice, that is collection. Set means a well-defined collection, not normal simple collection. It is a well-defined collection of sets. Right? I will give another example to understand the difference between set and collection. That is, see, my next question is, name the subjects. Name the subjects of class 10. Name the subjects of class 10. So, I don't know which subjects you will have in Karnataka. For example, in Andhra Pradesh, it will be subjects like English, Telugu and Hindi. 3 languages will be there, 3 core subjects will be there like social studies, some may call this as social science or science, which consists of physics and biology, and ultimately last final this is maths, right? So these are the subjects I have in class 10, right? See, these languages will vary based on the state and selection, right? So if they ask to name the subjects of class 10, I will tell these are the languages I have. But if I ask name the toughest subject, name the toughest subject, I am searching for your comment. Name the toughest subject. You have faced. Toughest subject you have faced only regarding these. So which may be your answer? If these are your subjects, which may be your answer? I am expecting in your comment. In my point of view, for my toughest subject is Hindi. It is a toughest subject for me. So maths is somewhat okay. But for me, the toughest subject is Hindi. For you, comment. It may be maths or science or social studies or English or Telugu, or for you Kannada, or it may be Hindi. So when it comes to the question number 4, it is collection. Opinion changes. One may tell Hindi, one may tell maths, one may tell science, some may tell all. So those we will consider as collection. Question number 4 and question number 2 consider as collection. But when it comes to question number 1 and question number 3, name the subjects of class 10 means only these. So these we will consider as set. Nothing but well-defined collection of elements, right? Next topic is representation of sets. We have learned what is sets. Now representation of sets. It is two types. One is roster form, another one is set builder form. What is roster form and what is set builder form? For example, if I given the word mathematics, if this mathematics word, if I want to write in terms of sets, how we can write? That is in terms of roster form. All elements are nothing but all the words should be listed. All elements should be listed, separated by commas. Nothing but flower brackets, separated by commas and enclosed within flower brackets. Those are like M, A, T, H, E, M, A, T, I, C and S. All elements should be listed, separated by commas and enclosed within flower brackets. But you need to remember that repetition of letters or repetition of numbers shouldn't be there. One M is there, so this shouldn't be there. A is there, again here, no need to write these two. Next T here, again no need to write. So like that, repeated elements shouldn't be right. Now set in terms of roster form is M, A, T, H, E, I, C and S. If they ask to write the word in terms of representation of roster form is like this. If they ask it in terms of set builder form, what is set builder form? Set builder form is a type of representation of a set which we need to represent the all elements in terms of only one element. Nothing but all elements should possess only one single element. So that is like for all x is that x is a word in mathematics. Simple. X is a word in mathematics. X is a word in mathematics means that may be M, that may be A, all will come. So this is simplest form. Nothing but this is general method. When it comes to roster form, this will consider as easy one. So easily we can write. So this is, but this in terms of all the letters, we will write only one letter, that is X. For all X is that X is a word in mathematics. For example, if I consider a set natural numbers, so we know some of the letters which represent the sets. The set we will represent with capital letters, capital letters, it may be A, it may be B, it may be C, P, Q, R, so on. Set you can represent with any of that capital letters, but elements are nothing but words or numbers. Those we need to represent by small letters. Sometimes if they given the mathematics in terms of capital letters, you can use capital letters in the elements, but if they given like this, MATH, like this, you need to use small letters. Generally we will use elements with small letters, and we need to represent the whole set with capital letters, like this is set A, this is set B, like that. Now we know some of these sets in mathematics like N, Q, R, W, Z, C, so on, like this. See, what are these? These are also a set which represents, N represents natural numbers, right? These are real numbers, these are integers, so like that. C means complex numbers, W means whole numbers, so like this we will represent sets. Now if I write set N, this set nothing but set of natural numbers in terms of roster form. How we will write in terms of roster form means that set A, we consider that set A is equal to 1, 2, 3, so on up to infinity. This is the set of natural numbers in terms of roster form. This is in terms of set builder form, that is capital A is equal to for all x such that x belongs to n. Simple. For all x such that x belongs to n. That means what is 1? 1 belongs to n, natural number. So all numbers in terms of one word, that is set builder form. If this n is restricted to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which is in roster form. If this is a set, how we will write in terms of set builder form? That is capital A is equal to for all x such that x belongs to n. See guys, by this my work is over. Is 1, 2, 3, 4, 5 is nothing but for all x such that x belongs to n. These are all natural numbers. Is it correct? Is it only 30% correct? Why? Because natural numbers means 6, 7 also will come, 8, so on up to infinity will come. But what are these? Only up to 5. Then we need to write the condition for all x such that x belongs to n, comma. What is the condition? X is less than 6. X is less than 6. X is less than 6. X belongs to natural numbers. Nothing but 1, 2, 3, 4, 5. Or you can write x less than or equal to 5. Or you can write x less than or equal to 5. So both will be same meaning. So like that we will represent the sets in terms of two methods. One is roster and the other one is set builder form. And how we can convert set? We can convert roster form into set builder form, and again we can convert set builder form into roster form. Those are also maybe the questions. Now we will discuss types of sets. So many types of sets we have discussed. Those are finite set, infinite set, next equal set, equivalent set, joint sets, disjoint set. So these are some of the types of sets we have discussed. Those are finite set. Finite set is nothing but, for example, this is 1, 2, 3, 4. Finite or infinite? Finite number of elements, 1, 2, 3, 4, 4 number of elements. So which we will consider as finite set. Finite sets. Infinite set is nothing but a set which contains infinite number of elements. Nothing but simple natural number, real number. How many number of elements? Do you know? Infinite number of numbers will be there. Those type of sets we will consider as infinite. Finite means finite number of elements. Infinite means infinite number of elements in that set. Next, equal set. When we will call equal sets, two sets are equal. 1, 2, 3, 4. This is set A, and if this is set B, like 4, 3, 2, 1. These two are equal sets or not equal sets? These two sets are equal sets. This is 1, 2, 3, 4. This is also 1, 2, 3, 4. Here order is not important in terms of roster form and in terms of set. Order is not important. You can write 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 3, 2, whatever it may be, if we have same elements like 1, 2, 3, 4, if we have same elements, then we will call those two sets are equal sets. We will represent with A equal B. For example, if A equal to 1, 2, 3, 4, C equal to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, these two are equal sets. These two are equal sets. A equal to C? No. 1, 2, 3, 4. 1, 2, 3, 4. But 5 is there. Therefore, A not equal to C. Equal means equal sign. Not equal means not equal to sign. Next. These are equal sets. Now when it comes to equivalent set. So there is a slight difference between equal set and equivalent set. Equivalent set means n of A should be equal to n of B. N of A should be equal to n of B. For example, A equal to 1, 2, 3, 4, B equal to 4, 3, 2, 1. Equal sets? Yes, equal sets. These are equivalent sets? Right, equivalent sets. Why? Because n of A is 4, n of B is 4. N of A is nothing but number of elements in A. 1, 2, 3, 4, 4, 4. These two are equivalent sets. Here A equal to 1, 2, 3, 4. I will consider D is equal to A, B, C, D. D is equal to A, B, C, D. Is A and B are equal sets? Is A and B are equal sets? No. Elements are different. So not equal sets. A not equal to D. But what is N of A? N of A means 1 to 4 elements. What is N of D? N of D also 1, 2, 3, 4 elements. Here N of A equal to N of D. Therefore A and D are called equivalent sets. Equivalent means number of elements should be same. Equal sets means same element should be there. Next, joint sets. Next, joint sets. Joint set is nothing but, for example, A equal to 1, 2, 3. B is equal to 3, 6, 9, 12, so on. Nothing but multiples of 3. These two are joint sets or disjoint sets. These two are joint sets. Joint set is nothing but it should have at least one element common. 3 is there, 3 is there. So one element is common. So these type of sets we will call as joint sets. Not only one, it may be 2, 3, more than one. If you have any common elements, we will call it as joint sets. Next, when it comes to disjoint sets, disjoint set means if A equal to 1, 2, B is equal to A, B, is there any one single element common? No. So therefore we will consider as A and B are disjoint sets. Joint means at least one element should be in common. Disjoint means it shouldn't have any element in common. Simply we can call if A intersection B equal to pi, nothing but empty set. If A intersection B is equal to empty set, if you do intersection between these two, what will get? Empty set or nothing but empty flower brackets. So those type of sets we will call as disjoint sets. Here one thing we have missed, that is empty set. That is empty set. What do you mean by empty set? We can call this empty set as void set or null set. Those will represent with either this symbol or empty flower brackets. Simply empty set is nothing but a set contains no elements. A set contains no elements. Can we consider this as a empty set? No. This set containing 0 element. Nothing but having element 0. This is not null set. This is only null set. Is this null set? Is this null set? No. Why? Because in this set, null set is there. That means one element is there. So this is also not null set. Either this one or this one we will consider as null sets. Right? Let us discuss the concept difference between belongs to and subset. This symbol, nothing but this epsilon like that. This symbol we will consider as belongs to insets. This symbol, C, elongated C like shape. This one we will call it as subset. First of all, what is belongs to, what is subset? For example, if I consider a set A, that is 1, 2, 3, 4. So I consider only 3 elements, that is 1, 2, 3. In this set, when we will use belongs to, when we will use subset. Belongs to means, simple, in the name itself it is there. Belongs to means 1 belongs to A. 1 belongs to A. Nothing but 1 is an element belongs to A, present or not. That means 1 is present in A, right? This 2 belongs to A, right? 3 belongs to A, right? 4 belongs to A. That means is 4 belongs to A. 4 is in A. No, in that case we will write 4 does not belongs to A. Is small a belongs to A? No. Is set 1 belongs to A? No. Why? Because whenever we write belongs to, that means that whole, whatever presented here, that whole should be in between flower brackets. Is set 1 is there? Only 1 is there, but set 1 is not there, so we will consider this as does not belongs to. Did you understand? Belongs to means that should be present. Whatever it we have in that left side, that whole should be present inside flower brackets. So these are belongs to, these are not. Why? Because 4 is not there, A is not there, set 1 is not there, 1 is there, but set 1 is not there. So we will call this as belongs to. Now when comes to subset, see, subset is a very important concept in this sets, which is the basic concept of the calculus parts. So subset, what do you mean by subset? Subset means, I will give an example, then you can understand easily. Set A I will consider as 1, 2. Set B I will consider as 1, 2, 3, 4, 5. Set B is 1, 2, 3, 4, 5. Now, did you understand belongs to? Now when it comes to subset, I will write here A is subset or equal to B. I will write subset or equal to B. Nothing but subset. This symbol we read it as A is subset to B. A is subset to B. Subset means every element of A. Every element of A should be, every element of A should be in, should be a element of B. Should be a element of B. If every element of A is also an element in B, then we will call A is subset to B. Here, what are the elements in A? 1 and 2. Is that 1 and 2 present here? 1 and 2. Yes. Then we will write it as A is subset to B. Now, I will consider the C set. C is equal to 1, 3, 5, 7. 1, 3, 5, 7. Can we write A is subset to C? Like this, can we write A is subset to C? Can we write yes or no? Yes or no? In comment. Yes or no? Is A subset to C? Tell me guys, is A subset to C? No. Why? Because element 1 is present. What about 2? What about 2? What is this? Every element of A is also an element in C. Then only we will write it as A subset to C. In this not case, how we have to write? That is A is not a subset to C. Simple. If every element of A present in C, then we will write A is subset to C. If any, at least if single element is not present in C, then we write A is not subset to C. So this is the difference between belongs to and subset. In these subsets also we have two types. Subsets also we have two types. One is proper subset. Another one is improper subset. Improper subset. For example, if I consider set A is equal to 1, 2. If I consider set A is equal to 1, 2. From this set A, what are the subsets? From this set A, what are the subsets? See, already we have discussed how to write subsets for a set A. For example, if set A is equal to 1, 2, what are the subsets? I told subsets will start with empty set and end with set, same set. First subset should be empty set and next should be the same set. In between what we need, right? Set 1 and set 2, right? These we will call it as subsets, right? These we will call as subset. Now in these subsets, which subsets we will call as proper subsets, which subsets we will call as improper subsets. See, in subset we will use two symbols. See, if I write A is subset or equal to B, this is nothing but subset or equal to B. Subset or equal to B. A is subset or equal to B. So here I will separate these two symbols into two different. A is subset to B, A is equal to B. Nothing but A is subset or equal to B. By using these two symbols, This A is subset or equal to B, nothing but A is equal to B. That I will consider as improper subset. If the condition is A equal to B, this case set 1 comma 2. So this set 1 comma 2. This case is nothing but improper subset. When it comes to proper subset, this symbol we will use A subset to B. This is what? This is what? Improper subset. This is what? Proper subset. This is what? Proper subset. So what are the proper subsets here? Empty set, set 1 and set 2. From this, how many the questions will be like how many number of proper subsets and how many number of improper subsets will be there for any set. For example, if a set contains two elements, number of subsets are 4. Nothing but formula is 2 power n. What is n? Number of elements in that set. If a set contains two elements, number of subsets is 2 square. 2 square, nothing but 4 elements. In that 4 elements, how many number of proper subsets will be there? Which is equal to 3. How many improper subsets will be there? Which is equal to 1. For any set, improper subset is only 1 when in the case of same condition. Remaining all in terms of proper subset. Now the question is, if a set contains 3 elements, like set 1, 2, 3, how many number of improper subsets will be there? 1. What is that set? That set is set 1, 2, 3, same set. Now how many number of proper subsets will be there? If set contains 3 elements, how many total number of subsets is 2 cubed? Nothing but 8. In that 8, if one element is improper and the 7 elements are belongs to proper, 7 sets are belongs to proper subsets. Subset is also a set, remember. Now, if the question is, if a set contains 20 elements, then how many number of proper subsets? That formula is 2 power 20 minus 1. Why that minus 1? That 1 is belongs to improper subset. If they ask how many number of subsets, that is 2 power 20. If they ask how many number of proper subsets, 2 power 20 minus 1. If a set contains n elements, n elements, total number of subsets are 2 power n. Total number of proper subsets are 2 power n minus 1. Total number of improper subsets are 1. These are subsets. These are proper subsets. These are improper subsets. Right? From these also questions may come. Students, now I came with 2 very good questions and I am waiting for your comment of your answers. Let us start. If capital A is equal to 1, 2, 3, 4, check for true or false. True, or false, true, false, true. What are? I will waiting for your comment next. Next question. If A equal to 1, 2, 3, set 1, comma 2, state whether true or false. So this one, for this one, and for this one, and for this one. Waiting for your comment in that box. Do it. Now let us check. 1 belongs to A. 1 belongs to A. True or false? True. Set 1 belongs to A. False. Set 2, 3 is subset to A. True. Kindly check your answers and tell me how many of you get correct. Next one. If A equal to set 1, 2, 3, set 1, 2. Set 1, 2 is subset to A. Set 1, 2 is subset to A. It is true. Set 1, 2 belongs to A. It's true. Set of set 1, 2 subset to A. It's true again. Set of set 1 belongs to A. It's also true or false? It is false. Let me check your answers and comment whether how many of you get correct. Next we discuss the most important, that is power set. What do you mean by power set? Did you understand the subsets? Subsets means, for example, if I consider capital A is equal to 1, 2, 3. If I consider this as set A. From this set A, what are the subsets? Subset will start with empty set and end with set itself, right? And end with set itself. What is that? Set 1, 2, 3. In between, what are the sets will be there which are subsets to set A? That is set 1, set 2, set 3. First is empty set, next is set itself to any set. Next is single element, set 1, set 2, set 3. Next double elements, set 1, 2, set 1, 2. Next set 2, 3, set 2, 3. Next is set 1, 3. Next is set 1, 3. Again, don't write set 2, 1. Why? Because in set is repetition of elements is not allowed. Why? Because set 1, 2 is also equal to 2, 1. No need to write again. So these are the set subsets. These are what? Subsets. Now, what is power set? What is power set? Power set is collection of all subsets in a set. Collection of all subsets in a set. These are subsets. If we write all subsets in terms of a set, nothing but in terms of flower brackets separated by commas, we will call this as power set. We will call this as power set. That we will represent with P of A. If A is set, power set it will represent with P of A. Will represent with P of A. We know number of subsets formula. If n of A contains 3 elements, what is n of nothing but the number of subsets formula? Number of subsets is equal to 2 cube, right or not? 2 power n formula. Like that same, number of elements in power set. Number of elements in power set is also like n of P of A is also same formula, that is 2 cube. Number of subsets and number of elements in power set both are same. Why? Because those subsets only will be there in power sets. Therefore, number will be equal 2 power n, and for this also formula 2 power n, where n represents number of elements. Right? Now, this n of P of A is also called as cardinality. Cardinality of set A. Cardinality of set A, or cardinality of the set A, right? Or cardinality number. Cardinality number. Nothing but number of subsets. Nothing but number of subsets. We can call as n of P of A or cardinality of set. Nothing but n of P of A. For example, if set A is equal to 1, 2, 3, 4. Set A is equal to 1, 2, 3, 4. What is cardinality number? What is cardinality number of set A? Option A is 2 power n. Option B is 2 power n minus 1. I am waiting for your answer. Option A 2 power n. Option B 2 power n minus 1. Option C 2 power 4. Option D 2 power 4 minus 1. So out of this, which is the cardinality number of set A having elements 1, 2, 3, 4? Waiting for your answer in the comment box. 2 power n or 2 power n minus 1 or 2 power 4 or 2 power 4 minus 1. Nothing but 2 power 4. Why? Because cardinality is number is nothing but number of subsets. Number of subsets formula 2 power n. But n represents number of elements in that set. Here n number of elements are there? No, only 4 number of elements. So 2 power n is general formula, but 2 power n is not formula for all the questions. Based on the number of elements, value will be changed. This is cardinality number and also power set. Right? Hope you understand. Next we will go to some of the questions based on cardinality number and check. Before going into MCQs, let us discuss the last topics of the sets topic, that is intervals, and the last one is Venn diagrams. Let us discuss these two topics, and after that we will go for MCQs, where I require your comments, nothing but answers. So first we will discuss about intervals. Intervals means this is also a representation of a set. This is also a representation of a set. For example, For example, if capital N is there, how we will represent capital N in set form? In set form, we will represent set 1, 2, 3, 4, so on. Like this, we will represent integers also, minus infinity to so on, minus 2, minus 1, 0, 1, 2, so on. In terms of flower brackets, we will represent. But when comes to real numbers, if I consider set A is equal to, for all x such that x belongs to R, nothing but x belongs to real number, where x is greater than 1, less than or equal to 10. X is greater than 1, less than or equal to 10. How we will represent this in terms of roster form? How we will represent this set in terms of roster form? That is, capital A is equal to x belongs to R, greater than 1 and less than or equal to 10. Nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, we will represent real numbers in terms of roster form. Is it correct, guys? Is it correct? No. Is it wrong? Why? Because they asked real numbers, but what we have written? Natural numbers. Why? Because x greater than 1. What are the real numbers? 1.1, 1.2, 1.25. Infinite number of numbers will be there. But what is roster form? But what is the definition of roster form? All elements should be listed. Set of all elements should be listed. Did we listed all elements? 1.5 we have missed, 1.7 we have missed. So many number of elements. So when comes to x belongs to real numbers, we doesn't have nothing but we shouldn't use roster form. If you use roster form to represent real numbers, that is obviously wrong. Then in which form we need to use? Nothing but intervals. In intervals we will represent. We have 4 types of intervals. These we will call as closed intervals. These we will call as open intervals, nothing but open brackets. These two are semi-closed. Nothing but one side it is closed. Left side closed, right side open. Left open, right closed. Right? These are the 4 intervals we have. Out of these four, how we will use which one? Nothing but for which interval we need to use either open or closed, like that. See, if we consider a number lines for this, if I include the number a comma b, or nothing but, for example, if I include the number for this 1 comma 10, 1 comma 10, 1 comma 10, 1 comma 10. How we will represent these intervals in terms of number line? Those are, for example, this is 1, 10, 1, 10, 1, 10, 1 and 10. Right? This is a real numbers number line. From this, how we can represent which interval belongs to this and this? If I write 1 included, nothing but dark circle, 10 included dark circle, and if middle also if I dark, this is nothing but closed interval 1 to 10. Closed interval 1 to 10. Closed interval 1 to 10 is nothing but 1 and 10 also included. 1 and 10 also included, and also in between numbers. But when it comes to open, 1 and 10 should be open circle. 1 and 10 should be open circle, but in between numbers. So this will write as 1 comma 10. 1 comma 10, this is nothing but open interval, means 1 is not included, 10 is also not included, only in between 1 to 10. This open interval we can also write like 1 comma 10, like this. So close bracket, this is 1 comma 10 means 1 and 10 and also in between numbers included. This reverse close brackets represents 1 and 10 are excluded except 1 and 10 in between numbers, right? We can represent it either this or with this. When it comes to this, here 1 closed dark circle, 10 open circle, so in between numbers, so 1 comma 10. That means 1 included and also numbers between 1 to 10 included, but 10 is excluded. This one is open circle, 10 is dark circle, and also in between, so 1 comma 10, like that we will write. Now, how to see from the concept of intervals, how to represent set 1 comma 2? Anyone tell me? First one or second one or third one or fourth one? Which one of these will be matched to set 1, 2? First one or second one or third one or fourth one? Which one of these will be matched to set 1, 2? You can comment in the comment box. Which one of these set 1, 2 is matched to either this 1, 2, 3 and 4. You can pause the video and you can send a comment. I am waiting. That is, set 1, 2 means not all the, for example, set 1, 10. Set 1, 10. Which one of it is? It 1, 2, 3 or 4. Which type? All are wrong. Why? Because set 1, 10 means only elements 1 and also 10. If it is 1, if it is 10, only elements of 1 and 10 only. That means 1 dark circle and 10 dark circle. That's it. No need to dark in between and there and here. Only 1, set 1, 10 means only element 1 and also 10. Only that. If we write in terms of close bracket, 1, 10 means 1 also included, 10 also included and also in between also included. So this is the concept of intervals. If I write 5, 6 or nothing but if I write 7, infinity like this. This means in this interval, nothing but in this, if it is 7, if it is infinity, this is dark circle and through this we need to dark. And always remember, it may be infinity, positive infinity or negative infinity, we need to put open bracket. Why open bracket means we don't know which number is that infinity. So for infinity we need to put open brackets, right? It may be left side or right side. But when we are writing in terms of interval, like if we write a, b, it should be like 7, 8. It shouldn't be like 8, 7. This is wrong. This is correct. If you write, to take an example, why? Because a should be always less than or equal to b. That means left side number should be always less than or sometimes equal to b, like 1, 1. But it shouldn't be like 8, 7. 8 shouldn't be greater than that 7 in terms of intervals. Intervals, a should be always less than or equal to b. Remember this case. But when negative infinity and positive infinity came, in that case we need to put open brackets. Now how to represent these real numbers? If they x greater than or equal to 10, less than or equal to 10 means this case is x greater than 1, less than 10. This case is x greater than or equal to 1 but less than 10. This case is x is greater than 1 but less than or equal to 10. Greater than means open, greater than less than or equal to means this is closed, like that. But if they given for all x such that x belongs to R, for all real numbers, what we write? Minus infinity to infinity, open bracket. This is representation of real number in terms of set form, right? Now we will discuss Venn diagrams. Venn diagrams is nothing but simply representation of sets in terms of diagrams, or nothing but diagrammatic representation of sets we will call as Venn diagrams. Why we are calling Venn diagram is this is introduced by the scientist, or nothing but introduced by mathematician Venn. So John Venn. So we will call this as a Venn diagrams. Now in Venn diagrams we will use some of these symbols like union, intersection, minus and a universal set. So those all types of sets we will use in Venn diagrams. So when we will use union, which part is intersection, which part is a difference, nothing but a symmetric difference, normal difference, universal set, how we will represent it? This all will represent in terms of rectangle. Universal set will be represented by rectangle, and sets which are subset to that universal set will be represented with any closed figure. It may be circle, it may be oval, it may be like a tube-like shape. In any shape, through any shape you can represent sets in that Venn diagram. So this rectangle represents universal set, nothing but U. If we have set A and set B, those will represent in terms of circles. If these are joint sets, if these are joint sets. Now in this total part, if it is set A and if it is set B, this total part we will consider as A union B. A union B means this shaded part. But when it comes to intersection, nothing but common elements or nothing but common part in between A and B. So this part, this is nothing but A intersection B. This is nothing but A intersection B. If it is A, if it is B, if it is A and if it is B, if we write A, which part is A? This total part we will consider as A. This total part we will consider as B. So it may be intersected with A, but B means this total part. It may be intersected with B, but this total first circle is nothing but set A. Right. Next, what is only A? What is only B? This part is called only A. It's called only A or A minus B. This part is called only B or B minus A. This part is called only A or B minus A. What is this intersection part? What is this intersection part? This is called A intersection B. A intersection B. If you observe, is there any intersection between only A, only B? No intersection. Is there any intersection between only A intersection B and B intersection A? There is no intersection between these two. So they will be separated by these lines, right or not? That means from this you can understand A minus B intersection B minus A is equal to empty set. A minus B intersection A intersection B, A minus B intersection with A intersection B is also empty set. B minus A intersection with A intersection B is also empty set, and A minus B intersection with A intersection B intersection with B minus A. If you do intersection for all these three, what will get? Empty set. But if we do unions, from this, A minus B union of A intersection B, tell me guys, A minus B union with an A intersection B, nothing but A. B minus A union with A intersection B, B minus A union with A intersection B, nothing but B. If we do A minus B union B minus A, A minus B union B minus A, that we will represent with A delta B. A delta B, nothing but symmetric difference of A and B, of A and B is nothing but A delta B. A delta B means A minus B part and also B minus A part. But if we do union of A minus B, union of A intersection B, and union of B minus A, which is equal to A union B. Remember, A minus B, A intersection B, B minus A. If we do union of all those, is nothing but A union B only. Is nothing but A union B only. So we have so many properties regarding union and also intersection. When it comes to union will obey commutative law, associative law, distributive law, law of U, law of phi, like that. Right? For example, when it comes to union, so those properties we have learned, and when it comes to intersection also we have learned. Intersection will obey commutative law, associative law, and the law of U, idempotent law, right? Universal law. And when it comes to difference also we have learned. And when it comes to, so very important properties in this are De Morgan's laws. De Morgan's laws, you may strike that. So those are A union B whole dash is equal to A dash intersection B dash. Second one is A intersection B whole dash is equal to A dash union B dash. These are very important properties of this concept, that is A union B whole dash is equal to A dash intersection B dash. Nothing but here what is dash? This dash is nothing but, if we write A dash, this is nothing but complement of A. This is complement of A. What do you mean by complement? For example, see this picture. If this is A, guys, this is A means this hidden part, this part we'll consider as A. If I write A dash means except A. If it is U, A dash means U minus A. In that U is nothing but in the total universal set, if we remove A, nothing but this shaded part we will consider as A dash. This shaded part we will consider as A dash. Like that, if we write A union B whole dash, what is A union B whole dash? This is A union B. A union B whole dash means what? U minus of A union B. U minus of A union B, nothing but except A union B. That remaining part, except A union B, that remaining part we will consider as A union B whole dash. That we will write as U minus of A union B. When it comes to this, these Venn diagrams are see this. A union B whole dash. That means except A union B, except A union B, remaining part we will consider as A union B whole dash. That is also equal to A dash intersection B dash. Check kar lo. Next, A intersection B whole dash. A intersection B whole dash means U minus of A intersection B. That means except A intersection B, except A intersection B, remaining total part except this part we will consider as A intersection B whole dash. That is also equal to A dash union B dash. So these are the some of the properties of Venn diagrams, and there's different types of sets, how we will represent in terms of diagrammatic, right? Now come on guys, I'm waiting for your answers for these MCQs. Question number 1 is the number of elements in this set. The number of elements in this set. The question is very simple. We need to tell how many number of elements in this set. The question is order pair A comma B such that 2A square plus 3B square equal to 35. What is that? 2A square plus 3B square equal to 35. Where A comma B belongs to Z. Z is nothing but integers. If A comma B belongs to Z, 2A square plus 3B square equal to 35. Then how many number of elements in that set? How many number of elements in that set? That may be in terms of A comma B. Think guys, how many number of elements will be there? See, I will give an example, by that you can tell how many. Like for example, if I consider 1 comma 1. If I consider 1 comma 1. 1 comma 1 is in terms of A comma B. If I substitute here 2 into 1 square plus 3 into 1 square, what is that? 2 into 1 square is 2 plus 3 is 5. Is it equal to 35? No. Again, if I take 1 comma 2, 2 into 1 square plus 3 into 2 square, which is equal to, this is 2 plus 2 square, 4 into 3, 12, which is not equal to 35. Then which type of numbers, which type of integers we need to take to satisfy equal to 35? I'm waiting for your answer guys. Comment me whether it is option A or number of 8 elements, 6 elements or 12 elements. Let us think and tell. Or you can pause the video and you can find the answer and tell me. The answer is 8. Why? Because if I consider the numbers 4 comma 1, if I consider the numbers 4 comma 1, see, substitute here 2 into 4 square plus 3 into 1 square, 2 into 4 square is 16, 4 square is 16, 16 into 2 is nothing but 32 plus 3, which is equal to 35, Now from this 4 comma 1, how many number of elements we can write? See carefully. We can write 4 comma 1, we can write minus 4 comma minus 1. Why? Because this is whole square, minus 4 whole square also 16, minus 1 whole square also 16, and again we can write minus 4 comma 1, and again we can write 4 comma minus 1. By using this one number, we can write 1, 2, 3, 4 elements. Can we write 1 comma 4? Can we write 1 comma 4? 2 into 1 square 1, 2 plus 4 square 16, 16 3 is 48. No, 4 comma 1 is not equal to 1 comma 4. So by using 4 comma 1, we can write 4 elements. But total number of elements they asked. total number of elements. Like that 4 comma 1, is there any element? Is there any element? Can we write? Think once. That is 2 comma 3 also. That is 2 comma 3. You substitute and check. 2 into 2 square plus 3 into 3 square. 2 square is 4, 4 2s 8 plus 3 square 9, 9 3s 27, which is equal to 35. So from this 2 comma 3, minus 2 minus 3, minus 2 3, 2 comma minus 3, again we will get how many number of elements? 4. So 4 plus 4, total we will get 8 number of elements. Total we will get 8 number of elements. You can check still any other elements are there. So it won't be there for this equation. So answer is 8. So very good question. You need to analyze and you need to substitute by yourself, right? Then you can get how many number of elements in that set. Now next question, let S is equal to 1, 2, 3 so on up to 100. S is equal to 1, 2, 3 so on up to 100. The number of subsets of A, I will consider another set. The number of subsets of A of S such that the product of element A of S, number of subsets of A of S such that the product of element in A is even is. Product of element in A is even is. So tell me guys, so which one may be the answer? Option A, B, option C and option D. So what they are asking is, from that set S, what is n of S? N of S is 100. From this, if n of S is equal to 100, number of subsets is 2 power 100. Number of subsets is 2 power 100. But the question is, the number of subsets of A such that the product of element in A is even. Product of element in A is even. For example, 1 to 100 we have odd numbers, 50 numbers, and even numbers also we have 50 numbers. Total we have 100 numbers. In that, product of element in A should be even. Product of element in A should be even. Even numbers is nothing but what? Total number of subsets are 2 power 100 minus, if we delete odd numbers, nothing but all will be even. Nothing but subsets of even, subsets of nothing but odd numbers. 2 power 100 minus subsets of odd numbers will give subsets of even numbers only. Subsets of even numbers. Then which one will be the answer? Which one will be the answer? We will get product of element in A is even. When we will get even, even into even is even, odd into even is also even, and even into odd number is also even. Then when we will get odd number, so odd number into odd number only will get odd number. Nothing but 3 into 5, nothing but 15, like that. Now to get subsets of odd numbers, how many odd numbers we will have? Out of 100 we have 50. So subsets of odd numbers, nothing but 2 power 100 minus 2 power 50. So 2 power 50 are odd numbers. So 2 power 100 minus 2 power 50 is nothing but not 2 power 50. 2 power 100 minus 2 power 50 is not 2 power 50. So we need to solve like, you take 2 power 50 common from these two. So this will be again 2 power 50 minus 1. So which is the option? Option B. Right? Next question guys. Two finite sets have m and n elements, then total number of subsets of first set is 56 more than the total number of subsets of the second set. The value of m and n are. So guys, we have two finite sets have m and n elements. Means first set having m elements, second set having n elements. Then the total number of subsets of first set is 56 more than the total number of subsets of the second set. Then find the value of m and n are. Waiting for your comment. See, for example, if a first set having m elements, then total number of subsets in first set is 2 power m, which is equal to 56 more than the total number of subsets of second set. Nothing but second set will be 2 power n plus 56 plus 56. This is the condition. By using this condition, we need to find the value of m and n r. So I'll bring that 2 power n to left hand side will be 2 power n, which is equal to 56. waiting for your comment of m and n values. This we can do by using two methods. One is by using a substitution method. Instead of m and n, you substitute 5, 1, which should be equal to 56, or 6, 3, like that. You substitute m and n values, which will give the answer. What is that? If you substitute, this is nothing but if you substitute what is 2 power m minus 2 power n, you substitute, which will get answer. Substitute and check. Otherwise, this 2 power m minus 2 power n is equal to 56. Equal to 56. Can also we can write as, if you take 2 cube common, 2 cube minus 1. What is 2 cube? 8. 2 cube is 8. 8 into 8 minus 1. Nothing but 8 into 7 is nothing but 56. That 56 we can write 8 into 7. 8 into 7 we can write 8 into 8 minus 1. 8 into 8 minus 1 we can write as 2 cube into 2 cube minus 1. So this one we can write it as 2 cube into 2 cube minus 2 power 0. 2 cube minus 2 power 0. Right or not? Then this one we can write as 2 cube into 2 cube, nothing but 2 power 6. Base are equal, powers we need to add, minus 2 power. This is 2 cube. Then which one will be the answer, right? 5, 1, 6, 3, 7, 6 or 8, 7. So absolutely 6, 3 is the answer. Like that we can check. Either you can substitute directly or you can do it by using this. See, this method for most of the students it may strike how to take common like this. So better you follow substitution, option verification. Next one is, let Z be the set of integers. Z be the set of integers. If capital A equal to X for all X such that X belongs to Z, where 2 power X plus 2 into X square minus 5X plus 6 equal to 1. If this is the equation, then number of subsets of A are. Number of subsets of A are. Before finding number of subsets, we should know number of elements in set A. Then only we will apply the formula 2 power n, where n represents number of elements. That means if you know number of elements in this set A, then only we can find number of subsets. First of all, tell me how many number of elements will be there in this. Try and tell, and which one will be the answer. Which one will be the answer? That is 2 power x plus 2 into x square minus 5x plus 6. How we can write? X square minus 5x plus 6 we can write as x square minus 3x minus 2x plus 6 we can write. If we take x common, it will be x minus 3. If we take minus 2 common, again it will become x minus 3. So roots are x minus 3 into x minus 2. X minus 3 into x minus 2. So this x square minus 5x plus 6 we can write x minus 2 into x minus 3, which is equal to 1. 1 we can express as 2 power 0. Here base are equal. We can equate these to 0. Then it will be x plus 2 into x minus 2 into x minus 3 equate to 0. Then what are x values? X values are minus 2, 2 and 3. X values are minus 2, 2 and 3. These are x values. Then what is set A? Set A is minus 2, 2 and 3. Now you tell me, by using this set A minus 2, 2 and 3, number of subsets are, tell me 6, 8, 12 or 2 power n. If A equal to, n of A equal to 3 elements, number of subsets are 2 cube, nothing but 8. Nothing but 8. Hope you all understood, guys. Show your presence through like and comments in the comment box. Hope you all understood the concept of sets. If you have any doubts still, you can comment in the WhatsApp group. But I'm expecting likes and comments through about this video. Thank you guys. Thank you for watching. Thank you. And get ready for the assignment.